just gonna, so as any other lab, we got a reading and then checkpoint questions. By the way, this is your second to last lab. So if you don't know this already, the answers to the checkpoint questions are in the reading. That seems to be a huge dilemma still, but okay, we got this lab and one more lab. Then you're going to turn to page 4 where it says the objective. So in this lab, you'll learn to identify different climate zones based on the ratio between precipitation and potential evaporation, which is called the EP. So the ratio between the precipitation and evapotranspiration. Can you figure out what evapotranspiration is? Evaporation. And transpiration. Remember plant sweat? So that's that combined. So basically it's any water entering the atmosphere, either if it's from like a lake that's evaporating or from a plant that the water is evaporating off their leaves. That's called evapotranspiration. So as well as the effects of latitude, planetary winds, elevation, mountain ranges, and large bodies of water on climate. So everything my class has been talking about last week. This is basically a lab that sums up everything we've done. It does go a little bit higher than you need, like a little bit more difficult than the Regents will be. So if there's some stuff you're struggling on, no worries. A lot of it's not on the Regents and I'll help you through it. So for the procedure A, which is all I expect you to get done the first day here. I will give you another time to do procedure B, but let's start with procedure A. This is to be completed on the large diagram of an imaginary Earth-like planet. Assume that this planet is identical to Earth in all respects except for the placement of its oceans, land masses, and other surface features. So in other words, this is supposed to be an Earth-like planet, meaning, well, the equator's hot, the poles are cold. The winds that happen on Earth happen exactly the same on here. Everything weather-wise behaves the same way. But it's not, they do this as an imaginary continent or an imaginary planet so that you can't just say, oh, I know that places in Australia are hot, or Africa's, there's a desert, or there's a tropical rainforest in South America. They don't want you using your preconceived ideas of the world on this planet. You kind of have to use the concept of winds, latitude, elevation, nearness to a body of water to figure out the climate of the areas. Anyway, first start with lightly sketch arrows to show the prevailing wind pattern. I'd like you to draw 4 in each of the 6 sections between the marked lines of latitude. 1 arrow off the coast of each coast and 1 on the continent. So by 6 sections, I mean 1, 2, 3, 4, 5, 6. Well, where are you going to get those arrows? Here's the planetary wind belt reference table. Basically, you're copying these arrows onto this map. Make sure you put them in the right spot. Make sure they go in the right direction. Basically, copying this onto there. Moving on. Then it says, at the far right of each side of the planet, label areas of high or low pressure to correspond with the latitude. Here's where I want you to tell me if it's low or high. Here's a blank for number 1. Why don't you add this line? I want you to tell me if that's a high pressure area or a low pressure. Same here. High or low, 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 high or low. So you're going to label, what is that, 8? 1, 2, 3, 4, 5, 6, 7. 7 places just need an H or an L. Keep in mind, you can figure that out from the winds because winds blow from high pressure to low pressure. So wherever the butts of your arrows are should be your high pressure. The heads of your arrows should be low pressure. And then finally, the climate ratio is a ratio of the precipitation to the evapotranspiration. We're going to do math next time, but for today, all you have to do is the climate ratios are shown by the various numbers on the map. On the map, color the areas according to the climate designation shown below. So any numbers less than 0.4, you're going to color them brown because they're arid. By the way, do you guys know what it means to be arid? Okay, that is a vocab word that the Regents will use that is not taught in this class. I just expect you to know that arid means dry, and what does humid mean? Yeah, moist or wet. Now, I guess technically I do teach you humid, but again, it was a vocab word I expected you to know coming into this class. So with these numbers, you're going to use these colors. I have colored pencils in the back of the room. And you're basically going to use your colored pencil as a highlighter to highlight any of the correct numbers. I'm looking for a highlighter. So I'm going to just do whichever one is green. So I'm going to go with anything greater than 1.2 gets highlighted green. So when you find a number, basically highlight it green. You'll find, just like right here, once you have them highlighted, there's kind of like a chunk of them that are kind of grouped together. You can kind of shade them in. Oh, here's another one. Shade them in all together to show that this area is, what did we color green? The humid area. You're going to do that. There is more, and I can show you what that is. Report step 2 says, using the climagraphs provided, calculate the P to EP ratio for each of the locations. Record this information on the report sheet. So here you have 6 climagraphs, which show temperature, and then in the temperature over the course of the year. And then in the corner, they have the P, so how much precipitation there is. In this location, there's 85 inches of rain, and only 65 inches get evaporated. So we need to just plug that into the equation. Again, the equation is P divided by EP. So you take, so the P divided by EP, and you would get for this one 85 divided by 65. And let me plug that into my calculator. No, and this is where it gets more complicated than anything you're going to need to do. That's why I'm going to walk you through this. So maybe do this with me right now. So again, where did I get the P from? Right there. The EP right there. Plug them into the equation. P over EP. And for this one, you get round to the nearest tenth, 1.3. So you'll take that to the reference or to the table here, and you'll put in 1.3 for location 1. Then you go back and you're like, well, what does 1.3 mean? You go back to this chart right here. 1.3 is greater than the 1.2. So this is a humid climate. And then I want a description. The description is going to be coming from the actual graph. What do you notice about the temperature? It's pretty flat. So what do we say about this location? What can we how can we describe their weather? And not only steady, but consistent, but hot. Hot all year long. So that's what you can put here. Hot all year long. You're going to do that for locations 1 through, well, actually, we already did 1, so 2 through 6. But then the next part, that's only step 1. Step 2 is to find an area on the map that best fits the climograph and write the number in that location. We've got, it's humid and it's hot all year long. Where on Earth, or this imaginary continent, near the equator? So you're going to label that. And since it's humid over here, I'm going to say it's going to be none of these other locations. Well, I guess there are a few more, sorry. So actually all of these are almost. Yeah. Oh yeah, there are a couple right here. Good job seeing that. Those were all the green ones. So we're going to be, we need to be in a green area near the equator. So there's 2 sections where it could be. Because it's hot all year long, that's how I knew it was near the equator. So I would accept anywhere, like over here. You could have put it over here. Any of those would be good. The key is that it needs to be by the equator. I'll point out a couple of other things on this table. So you'll notice some of them have a normal pattern like we expect. Cold in January, February, gets warm June, July, August, back down to cold in December. Then you'll see some of these that start off warm in January, February, get cold in June, July, and August, and get back to being warm in December. What places on Earth might that be? Know that are coldest in June, July, and August. Mr. Miga's people, I know you guys have already learned this. My students, my daughter learned it on TikTok. What places in the world are coldest in June, July, and August? In other words, opposite our weather. This is going to be in the southern hemisphere. This is what it looks like. In the southern hemisphere, meaning the south of the equator, their seasons are opposite ours. So Christmas time for them, December, is actually their summer. So Santa Claus doesn't walk around in a big red snowsuit. For them, he wears his Bermuda shorts. They're like swim trunks, you know? Okay? So just keep that in mind. That if it had opposite seasons of us, that would be something. Once you finish that, there are very few, there are no Regents questions. There are the 4 post-lab questions. Again, you have all of today and all of Wednesday to get this done. We will start reviewing at the end of this week and moving on, because like I said, we only have 1 lab left, but even Mr. Miga's class isn't there yet. So we're not going to start that right away. But that does not mean you're going to have free periods, because if you notice on my board, we only have 28 class days left. That means 14 lab days left until the end of the year. Even though we only have this lab and 1 more to go, we're not going to be doing study halls. We're going to be doing review on almost every day that you're not given a lab. So starting Friday, and there'll be no just planned study halls. They will be review days. And I also want to point out at the very top of my board there, I talked about the lab practical, which is the lab Regents for this class. Yes, there is a Regents just for the lab called the lab practical. What it is we go and we set up 3 mini labs. And these labs are timed. You get 8 minutes at each lab. And I know that sounds like way too short a time, but trust me, they're nothing like these labs that are way too long. They're really short, and as long as you read the directions and do what they say, the 8 minutes is more than enough time. We're going to be giving that lab during lab on Monday and Tuesday, June 5th and 6th. I looked it up. You guys are on the Tuesday one, so June 6th is a B, I don't know if it's a B, D, or an F day, but it's one of the 3. So June 6th, instead of coming here, you'll go straight to Academic Hall. And in the room, we'll have 3 labs set up, and you take the labs, and that counts as 16 points of your Regents. And your Regents has 101 points total. So as long as you do pretty decent on the lab practical, you're on your way to doing pretty decent on the actual test. What's on the Regents, the lab Regents, again, we don't know exactly what is there, but we know that it's the hands-on stuff. So it's all the stuff that you either had to have equipment or stuff in your hands to do. Like obviously rocks and minerals. We did all hands-on for that. We did hands-on for when we cut up the Play-Doh for density. We did hands-on when we did the earthquake stuff, when you needed to use the compass. When we did the humidity and we used the sling psychrometers, that was hands-on. So anything that's hands-on is fair game for that practical. And like I said, we'll start reviewing. We're going to start on Friday. My other classes will start on Monday. But it is during this period. So if you already know you're not going to be in school June 6th because you have a doctor's appointment or something, it's okay. Just let me know. I'll get you scheduled in there. If you're absent, again, it's not a huge deal, but send me a message in Teams as soon as you know you're not going to be here, or come down the very first thing the next morning. Because this is timed, I can't just like say, oh, just do it whenever. We have to have like a strict schedule. So it'd be best just to show up to school on June 6th, at least for lab. Let me know if you can't be here though. It's not a huge deal. We'll figure it out, but we just need to plan it if you're not here. Okie doke. That's it.